on bridging disciplines, innovative sustainable resource management through multidisciplinary collaboration and team-based research. In today's world, the challenges we face are increasingly complex and interconnected. As such, the solution we develop must be equally innovative and far-reaching. Today's session is just not about sharing knowledge, but about fostering the kind of collaboration that leads to real-world impact. We'll hear from experts across various fields who are pushing the boundaries of what's possible when we bridge disciplines. Together, we'll delve into how team-based research can lead to more sustainable practice and policies. I encourage everyone to engage actively with the ideas presented, ask questions, and think about how we can apply these insights to our own work. Together, we have the opportunity to push the boundaries of what's possible and to shape a more sustainable future. Okay, let me introduce today's resource panel. Professor Nalin Prasanna Ratnayaka is a senior professor at the Department of Earth Resources Engineering, University of Moratuwa, Sri Lanka. He completed his BSc in Geology from the University of Peradeniya in Sri Lanka in 1996, followed in MSc in Marine Geology and Oceanography from Shiman University, Japan in 1997, and later earned his PhD in Marine Geology and Oceanography from Hokkaido University, Japan in 2004. Professor Ratnayaka has held several prestigious positions throughout his career, including Vice Chancellor of the Ocean University of Sri Lanka from 2019 to 2021 and Head of the Department of Earth Resources Engineering at the University of Moratuwa in 2019. In recognition of his outstanding contribution to the field, Professor Ratnayaka was awarded the prestigious Ananda Kumarasamy Medal in 2024. Professor Ratnayaka is a renowned expert in marine geology and resource geology with extensive research and academic contribution in this field. Our next resource person is Engineer Nimila Dushanta. He is a marine engineer who graduated from the Faculty of Engineering, University of Moratuwa, earning a BS Engineering Honours degree with a specialization in mining and mineral processing in 2015. Following graduation, he successfully completed a Master of Philosophy in 2019 and Doctor of Philosophy in 2024 at the Department of Earth Resources Engineering. Recognizing his outstanding contributions, he was awarded the P.G. Correa Medal at the Young Geoscientist of the Year 2021 by the Geological Society of Sri Lanka. Engineer Nimila Dushanta actively engaged in collaborative research with Monash University, Malaysia, in Global Rare Earth Industry Association in Belgium, Ceylon Waste Management Private Limited, and Lanka Phosphate Limited, Epawala. Currently, he serves as a lecturer at the Department of Applied Earth Sciences, Faculty of Applied Sciences, Uvellasi University. We warmly welcome Sir and Dr. Nimila. Okay, to kick off our discussion, I would like to ask, how can bridging together diverse disciplines and research teams solve this?
Thank you, Dr. Naik. Let me go to my presentation. Dr. Nimila and myself has selected this topic, bridging disciplines, innovating sustainable resource management through multidisciplinary collaboration and team-based research as our topic today. Yeah, just to highlight you why our sector, both Dr. Nimila and myself work in mineral sector, how collaboration and team-based work is necessary. I would like to point out how different component of mineral sector works. For example, it has 5 major components: exploration, extraction, processing, reclamation, product development, marketing, and sales. Exploration means searching for commercially viable mineral deposit through surveys and drilling, either in ocean or either on the land, underneath the ground. And then extraction means mining. Processing means you separate important critical material out of the minerals that you are going to take out. Reclamation means, you know, you have to restore it back to normal, and then the product development. So it is itself a collaboration. Now, for example, to successfully complete this kind of mineral sector project, we need to have different experts in different fields. For example, geologists, mining engineers, operation engineers, metallurgists, environmentalists, and so many. Without that, it is, difficult. Now, when we come to research, to successfully carry out a meaningful research, meaningful applied research, we alone, one person alone from one of these sector will not work. So that at least few of us has to get together from different areas, then only we would be able to achieve meaningful research. Now, here that I want to highlight you, how do we foster a collaborative and team-based environment in our research group. Before that, I would like to say I joined the department in 2005. Before that, I was in Japan, and I was doing my post graduate studies for 9 years, and also postdoctoral fellow in one of the best universities in Japan. It was a research-based university, and I saw there are many PhD and in-field research students, and they are coming up with new ideas, new products, new papers, always. But once I came to Morocco University in 2005, okay, even though everybody of us have seen that in abroad, that culture was not there. So I was actually struggling at the beginning, and also inside the department, we are not even sharing resources. It was happening inadvertently. We are working as a separate unit. But later on, our department realized this won't going to work. So we started to collaborate. And for example, think about now if we go, when we are in the mineral sector. So what happens now if we go and find a new mineral, to sample that, we need the equipment from geological laboratory. And then once we take it into the university, we have to grind it and powder it. For that, we need mineral processing laboratory. And then to analyze, we need analytical laboratory. So without together, we can't come up with a meaningful project. So at that time, our research was also not that good. And later we realized, no, it won't work. So that we started to collaborate each other. First in the department, and then to the outside department like civil engineering, material engineering, and then to the outside institutes like Geological Survey and Mines Bureau, NARA, and then Ocean University and Berlin University. Not only that, but also countries, other association abroad, so that we became better and better. And our research group teachers were working with me. Now they have done different things based on the studies that we have done here. And also, we made sure there's a collaborative environment whenever there is whenever milestone is happening. We used to carry out deep discussion. So we give opportunities for students to give their opinion starting from the proposal stage until writing stage. We consider opinion of everybody. We critically analyze, the ideas, and sometimes harsh even. So that has given us opportunity that, whenever new student comes into group, automatically without even our input, because of the atmosphere that we have, they become better and better. I have seen this even in Japan. Ordinary students, they become better person, very high standard scholars after going through this research program, MSc or PhD. They become very good. So that we wanted to do it at our department also. Now it has become into much better environment. And also we encourage students to participate in interdisciplinary workshops and seminars and conferences. I think one of the results now entirely different, but Nimila is the editor of the Geological Society of Sri Lanka. It's completely different. Now he has learned from that, even though he's a mineral processing engineer. And also we encourage joint publication so that different ideas from people comes and we improve, and student improve, we as a group improve. And also we make cross-discipline training, and also encourage to skill sharing such as software, because for successful publish a paper, we need maybe 6-7 softwares. Maybe one teacher knows 2-3 softwares. And then if there's a team, then different people know different things so that we can improve that, like modeling programs, research methods, and methods, data analysis method. We do that collaboratively. I think that has turned us a better research group, and we have come up with better results.
So especially when I start joining this research group, what I felt was that not only I saw you as a lecturer and also the other team members, but also I have seen most of you in other forums, for example, Geological Survey and Mines Bureau, and sometimes at that time you are the editor, and those things. I got very motivated to join the entire team. When I joined the lab, when I was there, there were some let's say fellows that who completed the PhD and just come to Sri Lanka. So I got the opportunity to learn a lot of things, especially how to write a manuscript, what are the softwares that we need to use, and then how to collect samples, how to analyze them, and especially to develop the research design and do the analysis accurately, and finally compile a very good manuscript, and then how to target the, for example, Q1 journal. So that experience I gathered from the students available at the lab, it was, that made me a better researcher. And I think that foundation was there. Otherwise, I not be able to reach this level and finish the PhD with a good note.
And now I will, this has given us much benefits. For example, our laboratories has a laboratory environment, has a friendly working environment. Students now come. They don't usually give up. Most of the students, not only our group's students, completed their postgraduate, except perhaps one, because we made mistakes at the beginning. Because we also learning at that time, but that has made, and also enhanced problem solving skills has come, because different ideas, different people, different researchers are contributing, so that has helped. and increase efficiency, higher quality research outputs. For example, at the beginning in 2005, it was like we were publishing in Q3 journals. Now that we are publishing last year, I can't even imagine about 5 Q1 papers has published. So, yeah, from our lab. So that has gone up, and we have now broader perspective because it's not only mining sector people we are working. For example, very recently we got a student. Actually, there was a nickel deposit. I will come into this in detail later. Nickel deposit but low grade. Nickel is high priced, very high value. But we can't mine that area. Why? Because it's environmentally, it's a very foresty area. So we can't do that. So what we wanted to come up with phytomine. Phytomine means plant certain type of plants and then extract. So for that we needed the biologists. So that biologists came into that, and two biologists, good scholars came into our group. Now that we have broadened from that sense also. And also we got improved learning and skill development, as I said, software and all that. And it has also made a greater impact. Now that we are not only thinking about research output, I mean research papers, but we are now thinking even product development. Yeah. Mila, you don't add anything?
Yes. In that case, as I explained previously, once we got some experience while working in the lab, and then when newcomers come there and join us, then we give all the knowledge and experience that we gathered at that point. Then he or she improved a lot and then deliver significant outputs as far as publications and other product developments are concerned.
So I will take some examples and then highlight what we are preaching. So this is actually the best project that we have done so far. Actually, this is Dimila's PhD work as well as Nadira's MPhil work. So here we were trying to study about critical metal and material exploration and development. So just I will give you one idea about what is this critical metal means. So there are 17 elements composed of 15 lanthanide metals and scandium and yttrium. So these are very important metals. Actually, modern green technology entirely depends on these rare metals. Now, for example, now imagine computers have become smaller and smaller. Why? Because technologies have turned into neodymium-based magnets. They are much more powerful than iron-based magnets. So there are many examples. I will highlight you that in detail. So we wanted to study that. We wanted to study about that. Now, for example, this is a very important sector, and China is dominating that. China, even though the technology is there in USA, Japan, and Europe, mining and producing people are China. Entirely, they are the one who are producing rare. So they are using it as a geopolitical weapon. So there's great demand for rare metals. So that we wanted to see that whether there is rare metals in Sri Lanka. So that was based on that we got a research grant, 40 million research grant from ahead. And by now that we have understood that it's necessary for us to work as a team. So these are the team actually we applied for this grant. There are several geologists, mineral processing engineer, chemical processing engineer, mining engineer, and two postgraduate. One is Nimila, Dr. Nimila, I should say that, and a statistician and economist. And from our geological knowledge, we understood that these are the potential areas, rock formation and mineral formations, that these things can be found. So we have carried out an in-detail investigation, including apatite deposit in Ekpaola, pegmatite. So all these deposits, we have carried out an investigation. And what we have found is, you can see at the bottom line, there is a rare metal around 0.48, about 0.5% is there in the, for example, apatite deposit. Apatite primary crystals, we add that. So now that I know that the cutoff grade for profitably mined, grade has to be at least about 1%, above 1%. Now this is 0.5%. Now there's nothing that we can do about that. So then our collaboration come into play. There are processing engineers, so they have come new ideas. So Nimila did the PhD on these things, and he would explain it.
So at this point, when we found that the deposit grade is for rare earth elements is around 0.5, we had two options. Either we can give up this due to this low concentration, or maybe the team discussed together. Then we had different people having different ideas. So then we finally the other option we have taken the other option that we can extract rare elements as a byproduct rather than the main product. So our main focus is hereafter we can produce phosphate fertilizers. While we producing the phosphate fertilizers as a byproduct, there is a potential to extract rare earth. So we came into that decision after a long discussion, because the collaborative work is really benefited us at this moment. Otherwise, due to this low concentration, maybe we could give up that. Can you go to the next slide? And then in my PhD, I developed this flow sheet. Let's say the process to extract rare earth elements from Nepal phosphate deposit. Then in the current context, we are able to extract about 60% of the available rare elements from there. Then now we are our focus is to build up a collaboration. Either we need the support from the government side, or maybe from China, to increase this 60% up to maybe around 80% or 90%. So that is the next step now currently we are focusing on. Now basic flow sheet we have developed. So now we need to optimize to extract these rare earth elements as a byproduct in economically viable method. Then this is a good story. When I started my PhD, the first aim is to have a good literature review. Then I was able to compile a good literature review with the support of all our team. Then I published it in a Q1 journal in 2020, and within 3 years' time, it received more than 400 citations. And very good story is that the global rare earth industry recognized our paper as it was the best paper in that week published related to the rare earth elements. And they contacted us. The secretary contacted me because I was the corresponding author. Then they put our paper in their newsletter as the best paper in that week. So then we created another let's say another source that we can make a collaboration the global rare earth industry. Then we had our entire team. We had a close contact with the secretary. He's the Dr. Nabil Mencheri. He was in Belgium. Then at that point, our main concern was that why China has a monopoly related to the rare earth elements. Then we need to analyze it. Although it is not the main focus of my PhD research, but it is a part of that. Then we contacted Dr. Nabil, and then we created a good let's say a good process to analyze it. Then he has at that time he had all the contacts with the industrial people. So then we prepared the questionnaire, and then we did a survey, and then we analyzed it. Then ultimately, with the collaboration of the global rare earth industry, we are able to publish that study in a top journal. So it was published in the top another Q1 journal, the Journal of Cleaner Production, Impact Factor over 10. Even in this study, to analyze what we gathered with the help of Dr. Nabil, we knew that we need the support from a statistician. Then we contacted Dr. Pasan Edrising in Maths department, and also we get the support from Professor Netling. He was a professor in Imperial College London. So altogether, we were able to compile a very top publication published in a top journal.
So before moving to the next section, I have a question to ask you. How do you guide students in conducting continental literature review like that as a foundation for their research?
Now, for me, actually, literature survey is the most important part. Now, you have seen that he has, before doing anything, he has published a review paper in a very, very good journal. And at the beginning, my first student, two students failed. Really failed, I should say that. Because that was also learning experience for me. Because they entirely depended on my knowledge. My means our knowledge rather than available literature, so they were not serious. So from that we learned a lesson, and then afterwards similar success and then other students' success with literature, we know that it is the foundation. So now that in my new students, after Nimila, there are the PhD and PhD students. Now that I'm going through, much more, very intensive literature review program. So, for example, I asked them to read at least 250 papers, research articles before coming into, recognize them as a good scholars. So they have to send me. I'm not very strict. Every week, what are the papers that they have written? They have read. And then what I do is now if they are going outside from the focus area, then I will direct them. Okay, you have to come into this, otherwise you will not be able to come like that. I give my opinion. So tell you truth, now they are very good, and I'm very good at. This is the foundation. Based on that, they can manipulate their presentations, writing papers, everything they can do, and they are also very successful in their life. So one of my students has become chairman Central Environmental Authority, and then dean in another faculty, and doing PhDs in Canada. They are not exceptionally bright student at the beginning. It's not something coming out of my scientific methodology. If you're serious about scientific methodology, research methodology, if you follow through, seriously, I have seen it in Japan also. But I have seen in the laboratories, if you are serious, then normal average student become better and better. So that is.
Have you read
yes, in the lab we put that target as 250. So generally, at least then a student was able to read around 100 and 120 papers.
Yes.
So then that target is, even though when I compiled my literature review, I think that the reference list includes more around 100 references, but still I feel that still there is a target. But then again, after I started the PhD, let's say after 2 years, still I try to reach that target. So it is a motivation when we put something big there, but it gives another opportunity that once I publish this initial literature review, then but at that time I was around 100 to 120 papers. Still then with that 250 number, I felt that again I have another chance to publish another review paper if I was able to handle everything and doing the research and writing the thesis and writing the research papers. Meanwhile, if I was able to write it, then it would be highly beneficial, and also that the paper that we published in Journal of Cleaner Production, again we had to do a good literature. So altogether, in my PhD, in the thesis, it is around 200 papers. The thing is that actually sometimes, for example, when we read about 50 to 60 papers, then we can grab that we don't want to read the entire paper. Abstract, especially methodology, and some key results and discussion, then 250 can be achieved.
Those who are listening this also, has to understand literature review is the most important. the way that I do and Nimila do is now different. Nimila, you can explain that.
Okay.
It would be helpful for the audience.
The thing is that, Dr. Rani, at the beginning when I was reading some review papers, they are kind of storytelling. For example, let's say some papers published in 2000 to 2015, those review papers are storytelling. But then I found that at that time in 2019, the new review papers, especially Q1 journals, they are not storytellings, but they are having some analysis. So analysis related to what happened in the past, what is happening now, the current state, and what will be happening in the future. So if the main success of that research paper is I have done it. During the compilation, I included what has happened so far and what is happening in the current situation, and in the future directives I align how can I do my research with the given future directives. That's in that perspective I was able to improve the necessity of my research to serve the mineral industry in the country. Nowadays, if you want to publish a Q1, review paper in a Q1 journal, probably you have to do analysis, good analysis, maybe with that flow. What has happened in the past, what is happening now, and what would be the future directives. With the available data, we need to include the analysis. Otherwise, storytelling, I don't think that with this ChatGPT influence, you have. I don't think that we have a chance to publish in a good journal. But if you do such kind of analysis, not only you are able to publish it in a good Q1 journal, but also I can promise that you will receive a lot of citations, because in that review paper within 3 years, we received more than 400 citations.
So that you want. Yes.
Yeah, now again to the research work that we have carried out, we also found that interesting scenario at rare earth in Empower Lake sediments. The logic again that we were discussing with the mining engineer from the phosphate Lanka Limited. He was the general manager there, and I said that our phosphate is not soluble. Phosphate is not soluble, so that's what we can't. That's what Khan doesn't easily absorb. So that he said, Nalin, there is Jayaganga going across this phosphate deposit.
As you see in the figure.
As you see in the figure, you can see here. So why not you check the lakes, and maybe there are also phosphate or soluble phosphate there, and also maybe there are rare earth metals similar to adsorbed into clays, because in China there are adsorbed such deposits. So Nimila carried out the research work, and you can.
Yes, when it comes to iron absorption clay deposit, when metals adsorb to the clay, it is easy to extract. Then our extraction cost would be really low. Then it is economically feasible to extract. So I think that research idea was built up during the discussion. When we were there, we had a field visit. Then we had this kind of a discussion. That's the place that we meet that point. So can go. So then we analyze the lake sediments, and here you can see the spatial and vertical distribution of these elements, and then with that result, I was able to publish another Q1 publication. Here I need to share one experience, because when it comes to Empower Lake sediment, it is a case study. Then how can we publish in a Q1 journal with a good global impact? That is a challenge at that time that I faced. Then I realized, even when it comes to Empower, it is a very small area in Sri Lanka. Therefore, this whatever we found there, it is a very specific to a very small area. Then my next challenge was how to publish in the Q1 journal. Then when I obtain these results, as a team we discuss. Every time when I say I represent the entire team. Okay. So then we discussed, then we did some analysis. I mean, we compare our values with the globally available resources. We built some, we prepared some figures, we analyzed with having some tables. Then we were able to, I mean, give a global impact with our results, comparing with the globally available resources. Then this paper become a very good analysis and good comparison with our lake sediment results and globally available results. Then comparing all these things, then I was able to publish in another Q1 journal uh, with the help of our team. Then, as Narisa said, if the iron absorption content is very high, then we have good results. But unfortunately, in lake sediments, it is about 34%. Then, can put the next slide. Then, with that study, at that time, it is not a significant value. Sometimes when we do our research, we do not get the results as we expected at the initial point. So this is one of that. We don't have a, I mean, lot of research to compile a good research paper. But we have something new and very small amount of research. Then as a team we discuss how can we publish this. Then that's why the importance of multidisciplinary study. Then with all the new ideas, I was asked to study about short communications rather than go for a full research paper. Then I studied what are these short communications, how can we compile a short communication with having small results, small amount of results. Then with that guidance, I was able to publish another Q1, publish in another Q1 journal as a short communication. So this paper is a short communication related to the Power Lake sediments. So that's the main important thing is that although we don't have results as we expected, but still, if you are capable of finding something new, not only in the results but also how to publish it, then short communications, sometimes discussions, those aspects are available in journals. Then you can have a chance.
And then we also selected gem mining sites. Gem mining sites are located mostly in Ratnapura area. So gem mining has a lot of minerals. Other than gem minerals, there are other minerals like even gold is there, rare earth metals there. So we were interested about possibility, and also radioactive minerals are there. So that we were interested about to go there and check for the rare earth metals. And what we have found is about 0.3 to 0.6% of rare metal. And I said that the cutoff grade is around 1%. So that here again that we need the collaboration from the processing engineer, Emil is a processing engineer, to upgrade it and see what can happen. Emil, you can explain from now on.
So here the initial value is 0.3. Then our team discussed. Then how can we extract rare earth elements from these resources? Then with the team discussion, we came into a conclusion that first, before the extraction, we have to upgrade it. Then in my PhD, I had to develop a process to upgrade the concentration. So I was able, with this flow sheet, I was able to upgrade it to 3%. So now it is beyond the cutoff grade. After the upgrade process, now we have a good chance to extract rare earth elements from the final heavy fraction, as you see in this figure. So these ideas, after we found the initial results, we have discussed. Sometimes we are having long, very lengthy discussions. Then only we came into conclusions. Otherwise, sometimes 0.3, it is very negligible. We tend to give up that. But with all the contribution as working as a team, we were able to upgrade it and we have a good chance. Then with that findings, we were able to publish again another Q2. I mean, in a Q2 journal. The other thing is that this is work that I have carried out at the beginning of my PhD. So with our project, we are having ICP-MS, I mean, inductive coupled plasma spectrophotometer. It cost us about 32 million out of 40 million that we secure. The problem was that at that time, it took more than 1 year to bring the instrument from, I mean, the company to our lab. But during that period, we contacted the Professor Rohan Chandraji at the University of Peradeniya. Then we discussed the collaborative work. Then he supported us because that instrument was available there as well. Then he supported a lot, Professor Rohan Chandraji. And then we were, even before we installed the instrument in our lab, we were able to publish this our work.
So by now that you can understand, because we don't have resources that much, and also we don't have grant, and sometimes we don't have knowledge also.
Yes.
The best thing is go for
Multidisciplinary
collaboration. And even at this context, I think especially now that there are not that many grants, this is the best approach that we can do. Still that we publish around 5 to 10 papers every year now for the last 2-3 years.
Yes.
We were doing that. Before that it was we are coming out.
Yes.
From here also I've been we have found out something very important. Now, for the first time, we have noticed the occurrence of heavy rare metals. In Sri Lanka, usually lighter rare metals are very common. But this is the first time that we have come with this. Now, for example, these are associated with the illama, but on the top of the illama, there was organic rich layer. And then we thought that, it's possible, because organic acid break into acid, organic compounds break into acid, and then the rare metal can be dissolved in that and maybe rich in that. So once we checked it, there was for the first time, there was heavy rare metals. We have not still published that. We are compiling the paper.
Here, the point that I want to share is that when we had the discussion, our main focus is that gem bearing alluvial layer. But when we go there, all the other materials they use only for backfilling. Then at the discussion we had in the field, we thought that why not we analyze the other materials as well. So at that point we thought out of the box. So then we collect samples from that organic rich layer and we analyze it, and then we found that we are having some heavy rare elements in that layer. Until then, there's no literature available for that case. Currently, that paper is under review in the Q1 journal as well. So then another good story that we like to share. This is one of my undergraduate research publication. So when I submitted this paper to the journal, so this study mainly focused on the heavy metal contamination in soil in Guinea-Galpelesa area, Nability area. So then we compiled the paper and submitted. There was a comment that the reviewer asked from us, how could you able to remove these heavy metals from the soil, because there are some skin rashes, skin rednesses, especially children in that area. There is a huge challenge to the health. So one reviewer asked us that how you can remove these heavy metals from the soil. Then I have to read some literature on that context. At that time, I found that there is a method called phytomining that we can grow plants from the soil, and these there are plants called hyperaccumulators. They specifically extract these metals from the soil and accumulate in high concentration in the plant. So I write it as a reply to that comment. Can we go to the next slide, sir? Then, as a team, we discuss that point. Normally, when it comes to mining, we damage the environment. No doubt. But this mining technique is very interesting because up to then, no one has done it in Sri Lanka. So, with that reviewers comment, we compile a good research paper and we compile a grant asset. And with that discussion, we were able to secure SRC grant from University of Moratuwa to implement the phytomining for the first time in Sri Lanka. That's it.
Yeah. Now that phytomining, as Emila said, is we need to find a hyperaccumulator plant. Hyperaccumulator plant means we need to find a local plant which can store about 1000 milligram, more than 1000 milligram per kilogram of nickel. So that once we, find out that we can grow that plant in that area and then harvest it and then incinerate it, and from that we can extract the nickel. So that is the procedure, general procedure. So what we have, the main finding in this research is we have found a local hyperaccumulator called Appluda mutica. So it's a completely outside the engineering field. No? So we need the support from a biologist. So we got the support from one of the professors in botany field, and also we got a student from Kenya University. She's also has a background, some geology background as well as botanical background. Botanical. So that story has become better. And one thing that I also want to highlight here. Now, nickel, when we carrying out this phytomining research, which is a serpentinite big deposit, about 1 square kilometer in size. So there is forest on the top of that, very unique for us, so that we can't mine it. If we mine it, it's damageable. No? So that, but when we carried out analysis of the soil, what we have found was a nickel concentration in some places is as high as 2%. World cutoff rate is about 1%. Profitable mining amount is 1%. So that we highlighted this paper and published. Now, they are mining it underground. Yeah, so this is the publication.
This is another publication. No? So, as a team, when we compile this with this paper, there is two things that this term soil to resource. I would like to share the experience that I had during my PhD journey. Sometimes we need to create very attractive titles, especially to target Q1 and Q2 journals. For example, currently it is really trending waste to resource. Those phrases are very interesting. So here, when I saw that, well to resource phrase, then we discussed among our team. Then we use the term soil to resource approach. That means from soil we convert it to a resource. Then title is really trending. Then when we submit it, then we have to go through the editors and reviewers. Then having this kind of a title with having good trending terms, we have a good chance to get published our work. And in addition to the phytomining, after in this study we found that the soil has a lot of high concentrations of very valuable metals like nickel. Then we compiled, as a group, we compiled another research grant. We secured it from Wells University to implement another new technique called electrokinetic mine. So it is the first time that we are going to implement in Sri Lanka. So they all come with these kind of discussions, what we can do next. So with some ideas from different, different people from different areas. Finally, not only the publications, not only the grants. Finally, we have a good chance to serve the mineral industry.
Now this work is actually another critical material called quartz, Thirivana. So that is available in Sri Lanka. What we are doing in Sri Lanka, from our understanding, is they are rich in silica, means more than 99.5% of silica. What they are doing is they grind it, powder it, and sell it abroad for a nominal amount everywhere. So, but we have found out at the bottom, you can see a table. Silica content is more than 99.5%, but the price varies according to the product that you are targeting. For example, from using silica, you will be able to produce fiber optics, and then chemically reinforced glasses. For example, this is chemically reinforced glass. This is the best market available now. And then we have special optical glasses, and then the glass bottles, all that, okay, is there. So that you can see that from the table, depending on the trace metal available in different products, you will be able to, produce these things. Now, when it comes to mining in our quarries, raw material, if we can target, exactly deposit having these kind of ranges, then we can export it for the product specific tasks. Then we can get a better income. So for this, what we have done was actually we got a support from industry. So actually we have built the laboratories, mining, processing plant together in the department. And then also mine manager, mines manager, mining and geological manager of that company, he did the masters with us. So this is outcome of that master. So industry collaboration is important, and he could also publish his work in this paper. It's a good paper available.
Mainly in our research, we are focusing on the technical feasibility. So now we are opening up to analyze what is the financial feasibility when we assess the technical feasibility. In such cases, sometimes we need some financial support, people having the background in finance, data analysis. So now we are collaborating with some studies with business faculty of University of Colorado as well.
Now, until now we were discussing about postgraduate degrees. Now this is an undergraduate degree. Here, for the first time, we have found out iron occurrence very nearby to Morto University. There are iron deposits in Sri Lanka, but they are not very rich. If we start a plant to produce steel out of that, within 3 months it would be finished. But we have found out actually from this information, you can see that the paper notice that say Kandam Ballet Partners in. So we went there. We made it finally a research project, and we carried out investigation, and we found an iron deposit actually. It is in the area called Talpiti. This is the way that we carried out the research, Talpiti Goda. And you can see that iron content is around 50, 45, something like that. Usually a very good deposit. Usually all the rock has about 5%, 10% iron. Okay, so a very good deposit is more than 62% is the best iron deposit. But if it is around 30 to 50, it's a low grade iron deposit. So that we have found out. Now that we publish this. Once we publish, it's finished. But it should not go like that. We should be able to start some sort of industry from that. So that since we are working as a collaborative group, so that ideas are there. Those who are working in the industry, they give the ideas. So from that, what we have concluded is now, I discussed with actually material engine department, and I said this problem. So he said there should be issue. Melva is a company, they are using scrap metals. they take it into one furnace and put it there, and then produce steel out of that. Dangara company, they produce that. So for that, they need flux to remove the waste. The fluxing material is usually called ferrosilicon. Ferrosilicon can be produced by those low-grade iron and also silica, that quartz. There are lots of waste quartz material that combining that can be produced. Now, for example, we are exporting every year, not exporting, importing about $300,000 worth of ferrosilicon. So now that our plan with our group is to go for this and see whether that we can produce ferrosilicon out of these deposits.
In our team, one of the main strength of our team is that when we go to the field, for example, let's say myself and Alisa, we went to the field, we had a long discussion in the field. Then we build up a story there. That story is our research paper. So, with the knowledge that we obtained from that field visit, even in the field, we created the story. We have a long discussion. Then we created the story. That story would be the research paper. So most of my research papers are the stories that we discussed during the fields, because then all of them are adding ideas. Then we can have a good cake and icing on the cake.
Yeah, before moving into the next part, if you have any question, you can ask.
Yes, sir. Yes, sir. Dear participants, if you have any questions, you can raise here. Here also there are some academics are here, so you can ask any questions if you have. Actually, so during your discussions, I saw there's good journey for students. This discussion is different when I compare with previous discussions what we held in research launches. We discussed the research design, then literature search, Indian systematic review, so many things. I think that the difference between the previous sessions and today, so you're always giving evidences what you have done with your thing, and also in the meantime you're motivating your students. So actually, it's very nice. Then, then what strategies do you use to guide these students from the project conception to completion like that?
As Nimla said, well, I have a theory. Means I think research is a story. It has to be a complete story. I will compare it. For example, stories has a beginning. Research has literature survey or introduction. And then stories has main characters, and the research has concepts, variables, and stories has plot. Some plot, no story, plot. And we have research methodology. And then stories has conflicts or fights and challenges. And then research, we have data analysis, challenges related with data analysis, and then in the story come into sort of resolution, and that's the discussion and conclusion. And then there's a moral for story. That is the recommendation. Okay, so that I always ask students to build this story from the beginning. From the very beginning, starting from the proposal stage, going into the fail, week by week, we build that story. So, whenever there is something come like this to make an output, then we have that story with us. And whenever there is presentation, official presentation to make, they have that story. So then only that we would be able to communicate it to them. On the other hand, when it comes to writing papers or thesis, they have that idea, overall idea. So that even though they make some mistakes, they have the overall idea so that they can write by themselves, do by themselves. So that thing that I try to cultivate always on
Then how do you balance this guidance from your supervisor with the independence need to drive your own research? Because then when you present your work, so I show them just completed your PhD. but then you have your own way, and then you have built something for you. Okay. Not
Good.
only the PhD,
Yes.
but you have so many things, you have gained many things, and you have contributed to industry as well. Then others can show that, see that.
Yeah.
So then, can you, what you
I think it is building up with the time I spent with my team, including my supervisors, the experience. That's why I mentioned the field visit story, because that experience, for example, how Nadine sir explained this thing in the field, then I was able to explain the same thing when I bring my students there. So then I see some good role models in our team. So there are different types of role models, but I was able to grab everything that they gave throughout my journey. Then I was able to cook a very good food. So it is something like that. And when it comes to writing, for example, especially in early days, I was receiving many comments from my supervisors. Sometimes as a student, sometimes it is annoying because then I have to change most of the things that I have written at that point. But with the experience and the knowledge I obtained from my team members and the experience that I gained from the publications, then only I experienced that when it comes to the end of my PhD, for example, if I write a manuscript and send to my supervisor, the amount of number of comments getting reduced. So then I think the time I spent with the team and the way they talk, the way they compile their ideas, the way they explain the stories, the processes, that experience is very important to a student to become a good research scholar.
thank you.
I will take another example and highlight the point that we are making, and then we can move on. Now that we are not only carrying out our work in land, we are also carrying out in the ocean. You can see that mineral resources, okay, that is the land, and then the ocean is there in that diagram. And then in the beaches, you have pulmonary-like deposits, and in the offshore also. So we have to carry out investigation for that. So for that, we have to carry out, we have to go from a vessel in abroad, offshore, and then carry out. You need advanced equipment like side scan, sonar, subtotal profile. Those are difficult techniques, and also you need people. So if you go alone and do the research, it won't work at all. It won't work. So it has to be, group based.
One thing I can add when I see these photos, we are having offshore field visit for one of Narin's module. So when I was at my third year of first semester in level 4, we went there. That is the field visit which made me here this one today, because when I was engaged in this field visit, first thing I felt that okay, I need to do some research in this area. For example, in Narinsa's oceanography area. Then my passion is to become a teacher. Then ultimately I was thinking that okay, doing a research and doing something new with the passion I have for research. Then Narinsa is the first person I met. Then to be honest, I'm not the one of the top student in my batch. So I'm a very average person. And I met Narinsa and told him that Narinsa, I want to do research with you. First, I I have seen a kind of a red light. Then again, after 1-2 weeks, again I followed Narinsa and said that Narinsa, I want to do a research with you. And he said, let's see. Likewise, I had to follow him more than 5 or 6 times. Then only he told me that, okay, let's do something.
No, I feel the same. I mean, at the beginning, I thought that, he's not the best of the student at there. Now he's the best, I think, in his batch. He's very good now, outstanding, because this scientific process has made him, a better person. And most importantly, passion is very important. If you don't have passion, nothing new. And people mature at different ages. Maybe you are not very good at examination. Some other things you can become very good. Because scientific methodology helps you to become a better person, better scholar, better teachers. Not only that, also better consultant. If you want to know, for example, in Mortal University, best consultants are the best researchers.
So, sir, what are the key factors do you consider when selecting postgraduate students for your
Passion.
research?
For example, passion, without a doubt. Now, I learned that lesson. Okay. For example, now at the beginning, I said that I failed with 2 students. Failed with students because I thought about, how, I mean, education-wise, whether they are very good or not. That all that but they wanted to, I mean, take time until they find an opportunity in abroad. So that was their intention at the beginning. So it won't work. After Nimila, I knew that passion is the most important. For example, very recent for the nickel project, that mining project. So there was 2 students. We interviewed actually. Our team actually interviewed. One is got a first class from Pennsylvania, and it's a geology background. Very well fit with our ideas. And then this girl, she's also got first class, no? Second upper. But one thing she said, she would give up her job and come and join to do the MPhil with us. She was doing a very good job. So that I knew that she has the passion, and she joined, and she is also performing very well. And she has published, I think, in 2 Q1 journals, something around that.
Q1 and 1 Q2.
Yeah. So that's that.
Then, after publishing this video, so then I guess when students will watch this, therefore then one thing I want to discuss with you. So can you describe your approach to writing and revising manuscript to submission to top type journals? Because then when Nimla explained his presentation, there were several Q1 journals. So then how can you answer these questions?
Actually, that is the story that I tell. You have to build the story first. I mean, if you have that story from the beginning to the end, building that story bit by bit is important. And then the literature, thorough literature. As many as he said that 100 papers. I would like actually MSc student, it's okay to read 100. PhD student at least 250 papers has to read. So then only that
you would student.
PhD. 250 is better, so that you have that background. And then thereafter, usually I ask the student, so now that by that time, because of that our storytelling, he had that picture in mind, so that he also knows the research method. He also asked them to follow the research methodology. Research methodology is important. Research methodology includes, building the research gap, finding the research gap, and then the research problem, developing the methodology and the data analysis part, and then also resources, timeline, all that planning is research design is very important. So that student has to carry out that. So that is the most important part.
Adding one point to that answer, sir, the main challenge I experienced is that, especially for Q1 publication, how we make our findings globally interest. Otherwise, these journals, editors, they don't allow us to publish in these top journals because Sri Lanka is a very small country. Sometimes even editor does not know where Sri Lanka is. Then when we compile the manuscript, especially the results and discussion part, we need to write our findings in global context, not in Sri Lankan context, or not, for example, not in Nepal context. We need to take examples from the global context, how we align our findings with the global findings, what are the pros and cons in our findings. If someone else doing similar research in another country, then we need to give some directives. Then if we add that icing on the cake, then only we have a chance to publish in a good top journal and having good impact factor. Otherwise, it is really difficult when we do research here in Sri Lanka and publish in top tier journals.
And also, fortunately, we have very good instrument ICTMS, so that's well recognized. And then once the student writes this manuscript, what we do is, as a group, we read everybody. Everybody read. We have about 5, 6. Senior researchers. Even students, they give their opinion. This is wrong, that is wrong, and you have to come up with this. And then the student, improve that manuscript. And finally, we sit down together with several teachers and all of the students, because for their research also they have to learn, and then we go through slowly everything. Giving our ideas, connecting and correcting, so that sometimes works, sometimes it works.
For example, when our team analyze one of my manuscripts, all the other research students are there. For example, if Naren sir comment the figure caption has to be like this, then they all know that how to write the figure caption. Then all together we improved as a lab.
PhD students, masters, MP, undergraduates, so that everybody know the research method up to certain extent. Yeah. So, yeah.
Shall we move forward?
Yes, dear participants, do you have any questions to ask?
Yeah, okay. If you have any question, you can also ask. Otherwise, I will. Now, for example, now this research, we are searching for marine resources. In that case, we can't be limited only to our department. So we have to work with those who are in the industry related to ocean. For example, so I have developed collaboration with Ocean University, and then also NARA, Lanka Hydraulic Institute, because we need coastal engineers for numerical modeling and all that, so that we develop that. And also now, for example, these are the instruments that we are using to carry out marine mineral investigation. One called side scan sonar and sub-bottom profiler, and then the echo sounder, advanced instrument, and then those are the data that is coming out of that. Those softwares are commercial. For example, this one sub-bottom profiler, this has to be taken from a software called Synopsis, very expensive. So we have to collaborate with the private sector, and then they analyze this data. When we are analyzing the data, we are not just asking them to analyze. We send the students, and the students go there and learn about it, and they come back. We could also purchase this software for a certain time, but actually knowledge has transferred from LHI to us. And then we also actually transferred up to a certain extent to LHI. LHI started sub-bottom profiling survey. They were doing only coastal engineering previously, but once our student joins, they have carried out this kind of surveys. This kind of surveys are very, very important. I think the only person they are because of that. And now, one other thing that research that we have carried out now, sand is a problem in Sri Lanka. So we think that ocean is solution. Now, river basin we mine sand. Large amount of sand is necessary. It poses a lot of environmental issues. So that we have carried out in a proper methodical way using those instruments, those methods. We have carried out a proper method in Sri Lanka and published our work. Okay, we got the information and published our work like this. Now even NARA is carrying out investigation the same way that we have done. And they are also collaborating with us. They are also looking for minerals offshore. So they are first collaborate with us. We have to find, we have to go to the research, we have to do the research, and like that after only they would carry out this one.
Adding to one point to that, when we need some support from the industry, especially Naren sir, we send there. We didn't ask they to do our job. We send the student, for example, Naren sir sent me there. Then I will learn how to do it. And then when I came into our lab, I teach all the other students. Then they all know that. One good example is ICPM. Naren sir sent me to Peradeniya University. Then Professor Chandrit sir asked me to do the analysis by my own. Then I know how to handle the instrument. Then when our instrument come into our department, then I shared all the experience that I obtained from the Peradeniya University.
Now, when it comes to this project, this is related mineral. Now, like in Sri Lanka, heavy mineral deposit, it contains titanium. There's a great demand. Many countries has come and try to mine all around Sri Lanka. So this mineral deposit formation and mining depends on hydrodynamics waves, because that is we are going to mine where there is waves. So to plan and carry out research, even carry out projects, we have to get together. In this case, we need support from coastal engineers, so that we are doing some work with coastal engineers, civil engineering department, and also from LHI to do carry out numerical modeling. So again, this is a collaborative work that we are performing. So in detail, actually, this is one other example related to breakup of Kaluganga river mouth, because we wanted to identify, mineral deposit formation. It is related to sediment dynamics. So we were carrying out sediment dynamics project. For that, again, we need support from surveys. Without that, we would not be able to. Coastal engineers surveys. So we together can carry out projects. There are many projects going on with, all this combination, and then we publish that. Okay. So I'm not going into much detail. I went very fast. This is just to highlight. You can see that for the last 3 years we have very high impact. The visibility is high.
Yeah. Not only two of us.
The entire group has a high visibility. Nemila within now, he has started his research 5 years back.
Yeah, in 2016 I started my MPhil. Then within last 5 years I was able to, having index of 12 and more than 800 citations, mainly because of our team effort and collaborative approaches. Otherwise, I did not achieve it that high.
We had about 10 to 15, around 15 students, postgraduate students. They all are doing very well. I said that previously. One student is dean at Uvavelas, one of the department, and one student became chairman of Central Environmental Authority. Many are doing PhDs in abroad. Doing very well. So I'm happy for that also. And just to highlight, this research, we were focusing on, Nimila's research. I would like to show you some of the achievements that he has made. He got the gold medal from PG. Can you talk about others?
So with all these publications and achievements as a team, so I was a student. I am really, so lucky to be the student of that team. So I was awarded this PG career as the best geoscientist of Sri Lanka in the year of 2021. Then I was invited to join a webinar as a guest speaker in a reputed journal, and also I was invited by IESL for two. First one is to discuss about the current status of Sri Lanka as the individual speaker. Then I joined that panel. It is also organized by the IESL. So even just finishing when I finished my PhD, I had these opportunities. So I was so proud to have these opportunities, and I'm so grateful to my team, our team. Otherwise, I was not getting these opportunities, because when you have this experience under your belt, then, for example, let's say our team in culinary made me here, then my responsibility is to produce another Nimila from my students.
And just to show you that this is our collaborative team.
Yeah.
Many.
All the collaborators are here.
Almost everybody is here. Even photographs.
Yeah.
Without them, we won't be able to as a group be success. Still, even though now some of them are separated and doing their own job, we try to keep them as a group. They also do their own research, so we contribute, they contribute. So resource base is there, skill base is there. Anytime our student can go. Yeah. But unfortunately now since there are no research grants, the system that we build is dwindling, is going down. But still they have promised. Whenever if opportunity comes, we will recreate it. Yeah, thank you.
Okay, thank you so much. So then, when you were explaining these things, so actually, I was thinking about then there are two lecturers, two researchers, two good teachers. And researchers providing so many. You always try to give a chance, try to give time to your students. Then he's discussing then how I am. Create another Nimila. Likewise, then how nice, actually. Thank you so much sharing your knowledge and experiences. Then the work you have done. Actually, the tradition is different from other systems because then, as I mentioned earlier, so we discuss different aspect of research methodology. But actually, I thought then this a different experience me as well, and I learned so many things in your industry, and I think students also learn a lot with your discussion. So thank you so much for your valuable time and the things you shared here. Then we'll discuss another topic again about literature searching and so many things. I think we have to discuss more. Then again we'll meet another research lunch. So dear participants, so keep in mind the power of collaboration and the potential that lies in our collective efforts. So think about how we can all contribute to the shared goals of sustainable resource management. So we'll meet again next month for another discussion. Thank you all and goodbye.
Thank you very much.
Thank you.